Hello friends, welcome to Awdhesh Academy. We were on real numbers and today we'll discuss about HCF and LCM. So before starting it, let's first revise a few concepts. So the first concept is of the prime numbers. So we have studied about prime numbers in our earlier classes. A prime number is a number which is divisible by itself and 1, excluding the number 1, like 2, 3, 5, 7, etc. All these numbers are divisible by themselves and the number 1. The next concept is of the composite numbers. A number which has more than 2 factors is called a composite number. Again, except the number 1 because 1 is neither prime nor composite. The next we have in this topic is co-prime numbers. Two numbers are called co-prime when they are relatively prime. That means two numbers A and B will be called co-prime if they do not have any other common factor apart from 1. Like, let's suppose 3 and 4 and let's take 26 and 15. Both these pairs of numbers are co-primes to each other because between 3 and 4 the common factor is 1 and also between 26 and 15 the common factor is 1. So you may have many such pairs of co-prime numbers. Also an interesting thing is the individual numbers need not be prime. Like here we have 3 which is a prime number, 4 is a composite number. In this case both these numbers are composite numbers. So basically there is no hard and fast rule that the individual numbers have to be prime or composite. They can be anything, just that the two numbers should be relatively prime, that is, they should not have any other common factor other than 1. So the next concept we have is prime factorization. Prime factorization is a method where we find all the prime numbers which multiply to form a single number. So for example, let's take 12. Now the factorization of 12 is, which means 12 can be written as 2 into 2 into 3 or 2 square into 3 raised power 1. Now take another example, let's say 30. Now the factorization of 30 is the following. So 30 can be written as 2 into 3 into 5 or 2 raised power 1, 3 raised power 1, 5 raised power 1. So this was prime factorization where we found out what all prime factors multiply to form a given number. The next concept we have is factors. Factors of a number are all those numbers which divide a certain number. So let's take 12 again. So the factors of 12 are of course 1, then 2, 3, 4, 6 and 12. Again the factors of 30 are 1, 2, 3, 5, 6, 15 and 30. Now the next concept is multiples. Multiples of a number are all those numbers which divide the certain number. So again taking 12 as an example, the multiples of 12 are 12, 24, 36, 48, 60, 72 and so on. The multiples of 30 would be 30, 60, 90, 120 and so on. Now the next concept we have is common factors. So between the two numbers, what are the common factors? Now again taking 12 and 30 as an example. Now let's find the common factors between the two. We find 1, 2, 3, 6 as the common factors. So we have 1, 2, 3 and 6. Now what is the highest of these factors? It is 6. So the highest common factor or HCF of 12 and 30 becomes 6. The next thing is common multiples. The common multiples of 12 and 30 are 60, then 120, and 120 will be somewhere here, which is 10 times 12. So the common multiples of 12 and 30 are 60, 120, 180 and so on. Now the lowest of these common multiples, which is called the least common multiple or the lowest common multiple or simply LCM, is the lowest of all these common multiples, which would be 60. So the LCM of 12 and 30 is 60. So this is what is the concept of LCM and HCF. Now let's check the other methods of finding HCF and LCM. So now we know what is HCF and LCM. Now we have a method of finding the LCM and HCF using the prime factorization method. So let's take 6 and 20 as an example. The prime factorization of 6 is 2 into 3 and the prime factorization of 20 would be 2 into 2 into 5, or you can write it as 2 square into 5. Also you may or may not write the 1 as the power, because if you don't write anything it is assumed that the power will be 1. So using the prime factorization method, HCF is defined as the product of the smallest powers of each common prime factor. Now let's first find the common prime factors in the given numbers, which is 2. Now the next thing is the smallest powers. So the smallest power of 2 between 2 raised power 1 here and 2 raised power 2 here is 2 raised power 1. So we have the HCF as 2 raised power 1. Now we don't have any other common prime factor, since 6 has 3 but 20 doesn't have 3 and 20 has 5 which 6 doesn't have. So our HCF is 2 raised power 1 or simply 2. Now next we have LCM. LCM in the prime factorization method is defined as the product of the greatest powers of all the prime numbers in the factorization. Now in case of LCM, we'll take the largest power of each prime factor. So the prime factors we have here is 2, 3 and 5. We'll product them and now we'll find the greatest powers of each prime factor. Now the greatest power of 2 among 1 and 2 is 2. So we'll have 2 raised power 2 here. 3 has a power 1 and 5 also has a power 1. So we may or may not write 1 here. So this comes out to be 4 into 3 into 5, which is 60. So the LCM of 6 and 20 is 60. So we have learned to find the HCF and LCM of given two numbers using the prime factorization method. Another important method is the Euclid's division algorithm. It is used to find the HCF of the two numbers. Now, do not confuse it with the Euclid's division lemma which we have studied earlier in the chapter. Now, let's take an example. Say we have 420 and 130, of which we have to find the HCF using the Euclid's division algorithm. Now, let's first recall the Euclid's division lemma, which stated that given two integers a and b, there exist unique integers q and r satisfying this equation where r is less than b and greater than or equal to 0. This was the Euclid's division lemma. So, the first step of the Euclid's division algorithm is to apply the Euclid's division lemma given the two numbers. Here, the larger of the two numbers will be our a and the smaller of the number will be our b. So, we have a is equal to 420 and b is equal to 130. Now, we have to find the q and r. So, let's divide 420 with 130. 13 3s are 39, 130 3s are would be 390, which would be closest to 420. We'll have this and we'll have 30 as the remainder. So, we can write 420 and 130 in the Euclid's division lemma form as 420 is equal to 130 into 3 plus 30. Now, the second step of the Euclid's division algorithm says that you have to repeat this process until you find the remainder 0. Now, since the remainder is not 0 here, we have to apply this lemma again. But now we'll apply to 130 and 30, which is the b here and the r here. And we'll repeat this process until we find the remainder as 0. So, in the next step, we'll have 130 as the a of the Euclid's lemma and 30 as the b in the Euclid's lemma, and we have to find the q and r. So, again, let's divide 130 with 30. So, we know 3 4s are 12, so 30 4s would be 120, which would be closest to 130, and we'll have 10 as the remainder. So, we have 4 here and 10 here. Again, the remainder is not 0. So, we'll apply it to b and r again. Now, we have 30 here. It's simple, 10 3s are 30 and we have 0 as the remainder. So, since finally we have 0 as a remainder, the HCF is the last divisor, which is 10. So, the HCF of 420 and 130 is 10. So, this was the Euclid's division algorithm. Now, this algorithm is very important for your exam's point of view. You may receive one question based on this algorithm. Now, this method was using the Euclid's division algorithm and the Euclid's division lemma. We have a simplistic way of doing this without using the Euclid's division lemma or the Euclid's division algorithm. Now, let's take the same numbers as an example, 420 and 130. Let's divide the numbers. We'll have 3 times 130 as 390 and we'll get 30 as the remainder. Now, we start doing the division here itself where the remainder becomes our divisor and the earlier divisor will become our dividend. Now, we have 4 times 30 as 120 and we'll have 10 as the remainder. Again, we'll apply the same method and the remainder 10 becomes our divisor and the earlier divisor of 30 will become our dividend, and we'll have 3 times 10 as 30 and we finally have the remainder 0. So, even in this method, we'll continue doing this until we get the remainder as 0 and the last divisor, which is 10, will be our HCF. So follow any method you want, you will get the same answer. So we have learned about the division algorithm, we have learned about the prime factorization method to find the LCM and HCF. Now we have an interesting property of LCM and HCF which may be useful for you in your exams. Now the property is LCM into HCF is equal to product of two numbers. Now let's suppose the numbers are A and B. So LCM A and B multiplied by HCF A and B will give you the product of A and B. So if any three of these given four quantities are given to you, you can find the other remaining unknown one. Now we have learned to find the LCM and HCF when the two numbers are given to us. But what happens in the case of a word problem? Students do get confused when to find the HCF and when to find the LCM in a word problem. So this is no textbook lesson. This is just to help you solve the word problems more easily and more confidently. So let's take an example. Say we have an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So here we have two numbers, that is 616 and 32. Now whether to find the LCM or HCF of these given numbers lies in the question itself. You have to look for if the question talks about distribution or union. Now like in this case we are talking about distribution, that is dividing these two bands into equal sizes. Like say you have a scenario where you have to divide sweets into equal groups, or you have to divide number of students into classrooms with equal strengths. All these cases are cases of distribution, that is you have to divide equally. There we'll use the HCF or the highest common factor. So the HCF of 616 and 32 is 8, which will be your answer. Next we have union, that is whenever the scenario says you have certain quantities coming together at the same point, at same time, etc., you will use LCM. Like suppose we have an example. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So, like we have seen, the question talks about two people, Sonia and Ravi, coming to the same point. So, we'll use the LCM here. So, the numbers are 18 and 12. The LCM of the given two numbers would be 36. So Sonia and Ravi will meet after 36 minutes. Now the next important theorem is the fundamental theorem of arithmetic related to prime numbers and prime factors. It states that every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Or it can be stated as the prime factorization of a natural number is unique except for the order of its factors. Now let me explain this using an example. So let's take 12 again. So the prime factorization of 12 was 2 into 2 into 3. Now this theorem states that you may change the order of the prime numbers, but the prime numbers will remain the same. That is, the prime factorization of 12 will have two 2's and one 3 no matter what. You can write it as 3 into 2 into 2. You can write it as 2 into 3 into 2. It doesn't matter. These are not different but the same thing. So this is all about the fundamental theorem of arithmetic. We may get a few questions related to this theorem. Now let's take them one by one. So we have, consider the numbers 4 raised to the power n, where n is a natural number. Check whether there is any value of n for which 4 raised power n ends with the digit 0. So here we have to find if the given number, that is 4 raised to the power n, will end with 0 or not. So for a number to end with 0, it should be divisible by 10. And for the number to be divisible by 10, it must have one 5 and one 2 as its factors, because 10 is equal to 2 into 5. Now for 4 raised to the power n to end with 0, we must have a 2 and a 5 at least. Now 4 raised to the power n can be written as 2 square raised to the power n or 2 raised to the power 2n, which means the numbers of this form will be of 2 into 2 into 2 and so on, depending on the number of n. So here we have our 2's which will be required for the number to be divisible by 10, but we don't have any 5 here. So we can conclude that 4 raised to the power n will never end with 0. Also, from the fundamental theorem of arithmetic, which says that the prime factorization of a number is unique. So we know that no matter what, the prime factorization of 4 raised to the power n will always have 2's in it and not 5. Thus, we can conclude that the number 4 raised to the power n will never end with 0. Now, next we have explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So, our first number is 7 into 11 into 13 plus 13. Let this number be a. Now, we can take 13 common and we'll have 7 into 11 into 1 plus 1, which would be 77 plus 1 or 13 into 78. Now, this number a will always have 1 and a as its factors. Now, we also find that 13 and 78 are also its factors. Now here 78 is a composite number. So we'll have many more factors of a. We know that a number to be prime, it should have not more than 2 factors, and the 2 factors should be 1 and itself. Now a already has 13 and 78 apart from the 2 factors, that is 1 and a. So a has to be a composite number. Now the next number we have is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now let this number be b. We can take 5 as common and we'll get 7 into 6 into 4 into 3 into 2 into 1 plus 1. Now the multiplication of this will yield 1008 and we'll have plus 1. This would give us 1009 into 5. Now again b will already have 1 and b as its factors, and now we find that it also has 5 and 1009. Now for b to be a prime number, it should not have any other factors apart from 1 and itself. But we see that it has 2 more factors. Thus, we can conclude that b is a composite number. That's it for today's lesson. Today we have covered LCM, HCF, Euclids division algorithm and the fundamental theorem of arithmetic. I hope the concepts are clear to you. Please go through the questions at the end. and revise your concepts. Thank you for watching the video. Goodbye.